Hello everyone, my name is Vikas Soni and I welcome you all in this lecture 3 of DP series, and in this video we are going to learn about the grid DP, which is also called as the 2D DP. And why grid DP? So this is just a DP on some grid. So you will given a grid and you just have to do something on that grid with using DP. That's it. And so let's just learn this using a question, because deep like for learning DP, solving question is the best method. So let's just learn it with solving the question, and let me remove this stuff. Sorry, let me remove the code, which is this one. Okay, nice. Okay, and by just so this is like the going to be the most important question of the video, because if you just understood this question, the 50% of the grid DP will be done. That's it. Because all of the other thing is just some change in states or some change in transition, but you are going to learn the main intuition of grid DP from this question. So let's say what this question says. So we are given a robot which is initially located on the top left corner, as you can see here, which is 0, 0th coordinate. Now the robot tries to move to the bottom right corner, which is this one, m-1, n-1 coordinate, and the robot can only move to either down or right at any point of the time. So if the robot is here, he can go to right or he can go to down. And we are given the two integers, m and n. So m is the number of rows and n is the number of columns. And we have to return the number of possible unique paths that a robot can take to reach the bottom right corner. So we have to return the number of possible unique paths. How we are going to solve this? M and n are less than 100, and you can say that it is a pretty famous question. Like 4 million submission is a huge thing. So how we are going to solve this thing? Okay, so the name of the question is unique paths. Unique paths. So we are given some random grid of size m cross n. Well, it is not a random, it is just a empty grid. Let's say the grid is like this. We'll forget this stuff. Shit. Let's say our grid is like this. Okay, this is a good grid. So this is coordinates. Okay. So like I hope that you know the how to get the coordinates. So it's like the coordinate of this element, this box is going to be 1, 3. 1 is just the number of row he is in, and 3 is just the column number he is in. I hope that you know this. Okay, and initially in the starting we are at this point and we have to reach this point, and there are many possible ways, right? So like one possible way is this one possible way can be this one possible way can be this one, other can be like this one, and okay, there are many ways. So how we are going to solve this? So if I read this question, if I would have read this question for the first time, I would say that like this is a counting problem. Okay, you have to count something, and the majority of the counting problem are mostly of two types. One is maths. So like there is some formula you have to make, like you have to analyze the case, and you have to make some of the formula of like combinatorics and get the answer. And the other way is the TP one, that for each, like at each position you find something, you find some data, and from this like you just find the answer. Okay, we will learn this DP way. Okay, so like before DP, just pause the video and try to solve this question on yourself. with DP, because by the knowledge you have from the last two videos, this question can be solved. So try to pause and try to solve this question. And again, the other thing is try to solve it with maths only, like by some permutation and combination. Try to solve this case, PNC. Okay, let me give you a hint for the maths one. So this question is done by stars and bars method. So try to solve this with both method, and like that is the main core of the learning competitive programming. So you have to find all of the ways that you can solve this. Like you have to think in all of the ways and in all of the topics. If you can solve that by that topic, how to solve it, or if you cannot, then why not? And you have to ask this question, right? So that's how from one question you are going to learn many things. So I hope that you paused for some time, tried to think for it, and if you have solved it, it's nice. Again, we let's say we have tried for maths and I can't make some formula or something. I tried with a DP, so I have to think now that like how to solve it with DP. Okay, it's like let's say I want the answer for this one. Then what previous data I need from this one so that I find the answer. But in the more better way, let's say like uh, just a second to come here. You know that either there are only two possible ways, right? This one and this one. So for here and here, like from these two cell, what data you need so that you can get the answer of this n minus 1 and m minus 1 coordinate. Sorry, this m minus 1 comma n minus 1 coordinate. What data you need? Okay, yeah, the most basic and this is very easy. You know that you have to count the number of unique paths to count till this n minus 1, sorry, m minus 1, n minus 1. So yeah, this the most simple state is having dp of ij is just the number of paths to reach this I comma j coordinate from 0 0 from 0 0 by going just right or down, right? So this is my state going to look like, and like you can see there are two variables. I mean dimen the dimension are is 2, so that's why it is set 2 right? So now how you are going to solve this with the states, right? Let's shit. So okay, let me just remove this thing. I don't know what I'm doing. Shit, I'm very bad at it, but forgive me. Okay, so now let's say you have the data, right? You have all of the data and you want to find how the transition are going to look like. Okay, so let's just think it intuitively or just by test cases. So for the to come till this 0 0 point, the number of ways are 1, right? Right. To reach 0 0 from the 0 0 coordinate, the number of ways are 1 that you don't move. To come this 0 1 is just 1, you take right 1 time. This is also 1, you take right 2 time. So for downwards, to come at position 1 and 0, to come at coordinate 1 comma 0, the number of ways is just 1. You just take down 1 time, right? So like you were here and you take down 1 time and you reach here. So that's the only possible way to reach this coordinate, to reach this cell. Okay, but that was easy. But now how do you count the ways to reach till this cell? How do you? So like there are two ways, right? You can see by just manually And like when you just take some observations, you will find that in the the value at this cell is just going to be the sum of this value and this value, right? So that's the observation we get uh, in this video. So let's say I make this 2, okay, and now we come at this point. You have to find the number of ways to reach this cell. What are the number of ways? And like how do you prove the transition? Okay. So let's say that the number of ways to come till this cell is 1, right? Is 1. So by that many ways you will come to this cell, and from this you go down. Or now let's say the number of ways to reach till this cell was 2, which is 1 is this and 1 is this, and you will go from this cell to this cell, and there is only one way. You go right. So it is going to be just 2 ways from here to here. I mean this one and this one. That's it. Like I hope you understand. So that it is going to just be a sum of these two values. That's how our DP is going to look like, and the transition is nothing but DP of ij, which is number of ways to reach this I comma j coordinate, which is just DP of I minus 1 j plus DP of I and j minus 1. So it is that you come this coordinate from the from the left, or you come from the up. So these are the two possible cases, and of course it was a counting problem, therefore you just sum the all possible ways. So that was it, and let's see how our grid is going to be look like. Let's dry run our code, I mean our logic. So this thing is again 1, this thing is 1, 1 and 1, because you just have to go right to come to, like if you want to reach this one, you will just take right 4 times. So that's why there is only one possible ways. And also you have to be careful while doing the code, because like see here, like at this cell there is no cell upwards. Okay, so like let's say when your code is trying to count the answer of this one 0 comma 4, so again he will do the dp of -1 comma 4, and this thing is going to give you a runtime error. So you have to be slightly careful while making the base case and the transition code. And okay, that was the case when you are coding. Okay, this is going to be one. Now like how we should move, that is also the case. So you can see that, like you can just, if you have the answer of this row, of this above row, you can get answer of this all of the values in this row, right? Is this true or not? Because at each point you need the value at this above and the value in the left. So if you are moving something like this, then this, you will have all of the needed values. So yeah, the one way is you just do the recursion. You come here, you call this, and it will call this and this. So that's why recursion is easy. But when you are doing the code with the tabulation method, you have to like think in which way you will traverse in the loop. So yeah, the answer in this case is simple. You will traverse this, then you go to the next row, you will traverse left to right, you go to next row, and that's simple. So this way is 1 plus 3 is 4, then this 1 plus 4 will be 5, this will be 6, this will be 7, then this will be 1 plus 2 3, 3 plus 6 6, 10, 15, 21 and 28. That's it. And this thing, and like in the last you have to think what is our answer. Like in many possible ways, the answer is sum of all of these values in this DP. But according to our state, the answer is just DP of m minus 1 comma n minus 1. That's it. And yeah, in the example also the answer is 28. So that's it. So now how should we code in this? This is easy. First we have to make a 2D vector. 2D vector, sorry, 2D vector, let's name it dp of size m, and vector of int n. Let's just initialize it with 0. Like, then what should be the base case? Base case. Okay, so one way of solving this question is can be like, you just have this as a base case, and then for each of the other values you just count it. But in that the problem is going to be again this one, as we talked before. You're going to get the runtime error if you go to this dp of -1 comma 4. So you have to be careful for this first row and for this first column. Or what you can do is you can just see the values are just 1 in the first row and first column. So why not just as a base case you just have the values as 1 and 0. So like you go in the first row, and you just do that dp of I minus dp of 0 comma I, which is all of the values of the first row as 1, and for int of I comma 0, I less than m, I plus plus, dp of I comma 0 is 1 again. Okay, now let me ask you a question. What if I had done this thing? Is it correct or not? Okay, so think and say me if it is correct or not. Okay, let me say that it is not correct. So tell me where is the problem will come in this case. So I just write this and write this. Now what I have to do is just start from the uh, first column. I mean, sorry, first row. This should be till m I plus plus. For int j is equal to 0, j is less than and j plus plus. What is our transition? Transition is nothing but dp of I comma j. Oh, sorry, I have to this j is equal to 1. The transition is the sum of the left value and the right value. That's it. And what I have to return? Return the dp of this last cell, this one, which is the cell of m minus 1 and n minus 1 coordinate. So this is it. Let's run this code. Let me see. Okay, this is correct. Let me submit this code. This is also correct, but let's just see that how my time complexity is very higher and the memory is again very higher. So okay, now comes the second point to optimize the code. Can I optimize the space complexity in this? Can I do this or not? So if you see that, like when you are solving the question, let's say when you are finding the dp at this cell, what are the two values you need? You need the values of this left cell and the value at the cell in the top, right? So you need the value of this cell. For this, you will need the value of this cell. Let's say you're counting for this, you need the value of this cell and this cell. So you can easily see that, like for each thing, I also need the value of this row, this upper row, right? Let's say I'm counting the value of this 4. I will need the value which is at this position in the upper row. So that's it. So in some temporary row, I will just store the row which is previous row. Then I will count all of the values for this case. Then I will make this row as a previous row, and I will count this case. I mean this row, and that's it. So that's how we can space optimize it. But I am not going to do this here. So yeah, it's your homework to space optimize this code. And the best case which will beat the 100% runtime and memory is solving it by maths. So please try to solve that by maths. And just a second, let me check if everything is correct. Okay. So like I hope that you understand this thing, and this was very easy, right? So we just have to think in the starting. We have to think what is how the like what are some observation and how the solution would look like. Then we knew that the DP is used in this question, and after that we think of state, then transition, and in the last we think of base case. Okay, let me give you a nice hint. Okay, so let me show my previous code in which I did a smaller mistake. This is my code, and in this code you have to find the error. You have to debug this code. This is looking very simple. The only thing is I have this base case as this one, and I check if I am not at the 0th row or at the 0th column, and that's what I do. Just try to debug this code, and this is a nice debugging question, bro. Try debugging this code. If you can't, I just write the error in comment. And okay, so like I hope you understand this thing. Now we come to the slightly harder part of this question. Again, this all thing is same, but there is also one thing you are given. So there is one obstacle also in the space. So let's say the obstacle are like this, and now you cannot go to this obstacle. So if the cell is like have some obstacle, you cannot go to this cell, and by this you have to get the answer, the number of ways to reach this bottom right corner. How you are going to solve this? And this is the most amazing question, like in the in this lecture. So like I request you to just pause the video and think for this some time. And after that thinking, like when you see the solution, you are going to be amazed that like by such a simple thing you have solved this one, right? If you don't know the solution, this will look very hard to solve. So therefore, just think think for it. Okay, so I hope that you have think for some time of this question, and if you have solved this in the first time, amazing. So let's try some test case, and I don't know what the solution is, but I mean, let's just assume I don't know what the solution is and how I am going to get the solution. Okay, so the name of the question is unique path 2. Again, we have some grid. So we have some grid like this. Okay, let's say the obstacle are this one. Sorry, let's say obstacle are O. This is obstacle. Okay, so the most like the important thing I saw is that if there are obstacle covering whole row, then you cannot jump from this row. So therefore the answer will be 0. But that doesn't matter in this one. So yeah, you have to also see if your observation are useful or not. Okay, that's obstacle are like this. How we are going to solve this? How? Okay, so like if you cannot think of it, then just take a smaller test case, a very small test case. Let's say this, that's it. And the obstacle is here. Robot start here, and the end point is here. It is goal. Then what is the answer? Okay, so if the obstacle was not there, then there will be two cases. One is this one, one is this one, but the obstacle is here. So like for all of the paths to reach G which came from this obstacle will not be there, right? I mean, what I was saying is that if you have some like big grid and just hope that there is only one obstacle, there is our robot. Sorry, okay. So there is a robot here, and you have to come till here. So now, if the obstacle is here, what is the thing you are getting? I mean, okay, let's see it. So like there are many paths, right, to come this point. So this one was one path, and this was second path, and this was third path. So there were three paths to come till this zero, and if the obstacle was not here, I mean, so by this three paths you will come to this code, right? So now what the thing is that if the obstacle was not there, then our answer would have plus 3 extra because there were three paths to come till this point. But now they are zero. Can you understand this or not? Right. So now my only paths are going to be just come till this point and go here. Right. So which is like okay. Okay, let me just remove this scheme. So now my only paths are this one. You come till this point and then you go to here. That's the only possible way to reach this point. Because there is obstacle, you cannot add the thing, and that is the only solution. If the upper one is obstacle, you will not add it in the answer. So that was it. What you do is that you just make the vector of int a 2D vector called dp which is size m. Let's say int m is equal to, oh shit, this is a very big name of let me just this is a big name. Let me initialize some other vector. Let's just call it vec is equal to this obstacle grid. Yeah, this is going to get me a more runtime, I mean memory, but I don't care about it for now. So now let's say the int n is going to be arr of size, which is the number of rows, and int n is going to be the arr of 0 dot size. Remember this if you didn't knew. So this will give me the number of rows, and this thing will give me the number of columns. So I make the dp of n rows and m columns. What is going to be my base case? It is going to be dp of 0, comma 0 is 1. I hope that there is no obstacle on the first path. Let me check if there is one. Is there a given that there are no obstacle or there can be obstacle? Okay, so there is not written if so yeah, the obstacle can be at this point. If the obstacle is there, so this thing will be 0. So let's say the arr of 0, comma 0. So if okay, so like obstacle, if this thing is 1, so I know that there is one obstacle. So if there is one obstacle, I cannot reach this point. So the number of possible ways is 0, or I mean else this will be 1. That's it. So after that I just run a loop and int sorry for int j is equal to 0, j is less than m, j plus plus. Like if this thing cannot be, if this is, I mean if I is equal to 0 and j is also 0, I just have to continue from here because I have already calculated its value. Now let's have some answer. Let's call it the answer. It is 0 initially. Then if I am not in the first row, I'm not in the first row, and the AR at this I minus 1j is also 0, which means this upper, like if I am here and the upper cell has obstacle, I know I don't have to count this. So if I am not at the first row because there is no upper cell in for the elements in first row. So if I am not in the first row and the there is no obstacle in the upper cell, then only I will calculate this thing. I will add it into my answer again for the column also. So if I am not in the first column and the value at the last point is 0, then again I will add here. I will add it into my answer dp of I and j minus 1. That is it. And okay, and I forgot one thing. The thing is that okay, if the obstacle is at this one, right? If this is one, there is obstacle, then this thing will be 0. Okay, I will explain this. I hope this is correct. Let me check. Okay, I got a wrong answer. I don't know why I got the wrong answer. So in n is equal to 0, n is this, m is this. I made the dp, initialized this condition, ARR of 0, 0 is equal to 1, then it will be 0, or else it will be 1, which is again correct. I run a loop. If I is equal to 0 and j is equal to 0, I continue. Else I do this, and then ARR I minus 1 j is 0, then only I do this plus plus, and if this thing is also, I do answer plus this case. And if let me say, like if at this bottom right corner there is obstacle, I know I cannot come till this point, I cannot come to this point, so this thing is will be 0. That this is this case. Okay, so again I have to check what is okay. Shit. What I did is that I calculated the value of dp of ij, but never put this here, so this is the case. I hope it is correct now. And let me see. I got again wrong answer. This is the error. I am getting 0 again. Okay, I don't know what is the error in this case. This is a tough one now. 0 dot size, 0 dot size. dp of nm, then dp of 0, 0 is going to be, if this is 1, then it is 0, else it is 1. Then I just run a loop. If I is equal to 0 and j is equal to 0, oh, this is not or, this is and shit. So if I am at the initial, like if the I is equal to 0 and j is equal to 0, so if at I am this point, then only I have to continue. Again, like, forgive me for this mistakes. Right, this is now correct. So I just submit this thing. Okay, this is again correct. The runtime is 100. The memory time is beat only 6% because I wasted memory in just making a new array here. instead of using this one. But again, that doesn't matter. Or what is the other thing you can do is that if at this ij, if this was obstacle, if this was an obstacle, you just do dp of I and j is equal to 0 and continue. So by that you don't have to check the case here. Okay, and you don't have to check this here. Let me try to submit it. Okay, this is also accepted. So I hope that you understand this thing. Okay, so the like if there is obstacle, what we did is that we just uh, store the value dp of ij is equal to 0 here, because the number of ways to come till this point is 0, because you cannot come to cell which has obstacle, and that's it. So like in this, if the question was this, we just did the new line we added in the unique path 2 is that if arr of ij is equal to 0, then we just did a continue. I mean, just store the dp of ij is equal to 0 and then continue. So that's it we do here. So that was like, just see, it seems very harder in first, but by dp, the only thing you have to edit is just a small line. So that's it. So that's why the dp is very useful. Okay, so let's say you counted the answer by maths in this case, which is just the stars and bars method on n and m. But by maths you cannot solve this thing, or if you can even solve this, it is going to be very harder for you. But like in the dp, it is very simpler, right? Let's say so because like if there can be many possible changes made in this question, but you can just make solve it by dp very easily, right? Let's say if you have to go to right in some of the rows, right? Let's say if you are at the in the first row, if you are in the first row, you get you have to give the extra 5. No, that's not okay. So let's say if the question can be like in the first row you cannot be more than three moves. You can again just solve it here, like right? Or let's say if there can be many other condition. I cannot think of it currently, but yeah, there can be many condition you can solve and solve this question. So I hope this was okay to you. If you have any doubt in this question, you can write in comment. Okay, so these three are the most important question in this one. Okay, let's say, okay, that's not, okay. So now let's say, let me see the third question, which is a hard one. It is also a nice question, and by solving this too, you should be able to solve this case. So try to think for this question for a minute. Okay, and just a minute. Okay, so I hope you have paused this one and think for this question. So what is the question is number of paths with max. Okay, let's just write as the question 3. So let's see that how we are learning the new concept by each problem, and that's how you have to learn DP, right? And the best way is to practice, just practice question. And okay, so the question is like that there is the grid grid given, and it is something like this. And in this grid, the top left cell is marked with X, and the bottom right with S. I don't know why it is useful, but let's have this E and S. Okay, so now we are at the bottom right corner. So instead of being here, we are at this bottom right corner, and now from this bottom right corner, I have to reach till this E. Okay, but what the condition is that the rest of the squares are labeled either with a numeric character, which will be 1 to 9, or an obstacle X. And in one move, you can go up left or up left. Oh, diagonally. This is a new case. So we can go up, we can go left, or we can go up left. Only if there are no obstacle there. And we have to return the list of two integers. The first integer is the maximum sum of numeric characters we can collect. And the second one will be the number of such paths that you can take to get the maximum sum. Take and modulo this one. This is a nice question. I hope you have tried for it. Okay. So, like when you are solving this type of question, you have to break that question in some sub problems. Right. So the first thing is that like from each cell, you can go to either left or up left. So there are three possible ways now. So if that was only case, let's say I say you to find the number of possible ways such that you move like this, and you have to reach to E from S. How many ways are there? Try to think for this question. So you see this will be again a very easy one, right? Which will be, I mean, you just do like dp of this one, dp of, I mean, like, sorry, let's say you have to find the answer of this cell, which is going to be dp of this plus dp of this plus dp of this, because from this you go, or from this you go, or from this you come. So that's the easy transition. Okay, so this was an easy question, but now again we have to care first. We have to return two values. The one thing is the maximum sum, and the other thing is the number of such paths such that their sum is the maximum sum. Okay. So how we are going to solve this one? How? So again, we will just see some test cases and try to think for it. And sorry, and after that we will take some observation. Yeah, that's what we do. So again, you will try with DP. I mean, you will try with some other case, or let's say you think of greedy, and you will see that the greedy cannot be applied here. So now you think of using some DP or using some maths, but this thing is done by DP because it is cannot be done by math. So let's say you are here. Okay, you are here, and you have already calculated the answer of some these cases. So what is the data you need from this one to count the answer for this thing? What is the data you need? So let's just break it with in a sub problem, another sub problem also. This sub problem will be, let's say you only need to return the maximum sum you can make. Maximum sum you can make. Then how you are going to solve this thing? So this thing is very easy. This thing is very easy. So it is just that like dp of ij is going to be the of maximum of dp of I plus 1j or let's write this is here dp of, sorry, I did the brackets wrong, so which is going to be 1 plus, so one move to go plus maximum of dp of I minus 1j, or dp of I minus sorry I plus 1j, I plus 1 j plus 1, or dp of I and j plus 1. So that's it. So if we have to think for like counting the maximum answer, only the maximum sum, it is okay. But now we have to think for the two. We have to return two things. The first one is the maximum answer and the number of possible paths that lead us to the maximum answer or maximum cost. How will you think this? This thing is again easy, right? Let's say, let's just try to make the state, I mean the state is equal to just the question. So let's say the states are like this. So dp of ij is the maximum sum we can get, and the other thing also we store is the number of paths to get this max answer, to get this max answer. So okay, this is the basic thing I did. So now if you have this thing, can you get the answer for other cells? Okay, what I'm saying is that, let's say if you have the data, this data for this cell, can how will you find the answer for this cell? How? Try to think for this thing. Okay, so this thing was easy. So let's see one test case, I mean one small case, and find this. So let's have this type of thing. The cost to reach this cell. Okay, let's just assume that this was a big grid, pretty big grid, and we have calculated answer for all of this, but that doesn't matter to us currently, because we are counting the answer for this one. The only cell that matter are this one, and this one, right? So let's say the answer for this is, let's say the maximum sum is 10, and the number of ways such that the answer is equal to 10 is 2. I mean the the maximum path sum you can have is 10 to reach this cell from this cell, right? And there are two paths like this. So let's say if this path also lead to the sum is equal to 10, and this path also lead to the sum is equal to 10. So there are two paths like this. For this case, let's say the thing is 7 and 3. So which means that from this cell to this cell to this cell, the maximum answer you can have is 7, and there are three paths such that go from this one and come to this one, such that they have the cost is equal to 7. And for this case, let's say it is 10 and 10 and 1. So now you have to think that if you can find the answer for this cell, how do you find? So if you have to just find the maximum, if you have to find the maximum, we know that how we find that, right? We know that how we find that, which is just this thing. Okay, but now how you are going to find the number of paths that lead to the cost is equal to maximum one? So in this you can see that if you have to come here, you will either choose this one or this one, because this sum is 10, both sum is equal to 10, and these two are leading us to the maximum answer. So that's it. So first thing I know is that the answer for this thing is going to be 10, but I don't know how many paths are there. So the number of paths will be just 2 plus 1, 2 plus 1. So the cell which have this is equal to 10. Sorry, I did a small mistake here. But I know that okay, this is a bad grade. So like the thing I know that is if I have to come here, I will only come from this thing or this thing because the cost is same, right? And the number of ways will be 3 in this. So that's it. So let's have some test case, some good test case, and analyze this. Okay, let's just take this test case. Right. The test case is like this. This is E1, 2, 1, X1, and 2, 1, S. Okay, this is our test case. And here we will make a DP. So this is our DP. Okay. In the initially this will be the base case. What will be the base case? So the answer here will be the max cost is 0 and the number of ways sorry, and the maximum I'm sorry, the max cost is 0 and number of ways is 1. Now to reach this cell, there is only one way, right? So what is going to be the max answer look like? Max answer will be, max cost will be 1, because the cost to reach till this point is 0, and after that you come to this and this cost is added, right? This will be 1, and again there is only one path. Sorry, there is only one path. If you count here, it is also 1 and there is only one path. Now this is an obstacle. This is obstacle in the middle one. So what we do is that just store the max answer is equal to, let's say, minus pretty big value, or let's just, I mean, if this is an obstacle, let's say you don't calculate its value. So this value is not yet calculated. You just skip this value, okay? And let's say you come at this point. So the cost will be, maximum cost will be this one plus this value. So 1 plus 2 will be 3. Sorry, will be 3, and the number of ways are just 1. So it means, it says that, so if you read this 3 1, it says that the maximum cost you can have to reach this point from this cell is 3, and the number of valid paths are only 1, which lead to the cost is equal to 3, right? So that's it. Now this thing will be 4 1, this thing will be 3 1, this thing will be 4 1. Okay, 4 1. Now you come here. So what is the maximum answer you can have? So the maximum answer is 4, right? Like either you can go from this to this, the answer is going to be 4 because there is no cost here, or you go from this to this and again the cost will be 4. But how many paths are there? So one path to come to this and go to this, right? because there is one path here and one path. So this is 4 1. So that means that there is one path to reach this point which lead to the maximum answer, and from here you go up, right? So the this thing will be 4 comma 2, and that is the answer. So let's see here, the answer is 4 comma 2. So that's it. So what you have to see is that, so let's say you calculate two values. So the first value is going to be the max cost, and the other value is going to be the number of paths that lead to maximum cost. Okay. And now if you are at some point, if you are, let's say, so now, I mean, let's say you are at some grid, you have the value of this one, and this one also. Let's say this is 5 5 2, this is 5 1, this is 2 3. Okay, this is 5 2. So now, and let's say the cost of this cell is 0. I mean, let's say this is E, this is the last point. So now you will check for all of this what is the minimum cost, sorry, the maximum cost. So the maximum cost is 5. Okay, but how many paths are there that will lead to the cost is equal to 5? So you will see that there is one path here and there is two paths here, such that the cost is equal to 5. So that's what you do. So this thing is going to be just 5, and this is 1 plus 2. So 5 and 1 plus 2 is equal to 3. So now this point will be, so dp of this will be 5 comma 3. So that's how our code is going to be look like. So let's, I don't think we are to dry run on this case. Okay, so initially how our code is going to be look like. So let's say int n is equal to the size of the board, I mean the number of arrays, sorry, number of rows in this vector board, and int m is equal to board of 0 dot size, which just say the number of columns in the board. Now we have to make some dp vector of int dp, which will have size n cross n. Sorry. Now first thing we have to think of is the base condition. What is the base condition going to look like? So the base condition is that is to just count for this value, this s, and what will be this value? So the minimum cost, oh, this thing will be pair of integer. So at each point we are storing two values, right? The first one is the maximum cost, and the second one will be the number of paths. Okay, so now the base condition would look like the dp of n minus 1 comma n minus 1 is what? Is something like this. So let me write here dp of ij would be a pair, and this pair will give me the max cost to reach I comma j, this index, this coordinate, and the second value will be number of paths that give the max cost. Okay, so that's it. Now what is the base condition? So what is the max cost to reach this n minus 1, m minus 1, it is 0. And what are the number of ways? It will be 1. Now again you have to run a loop in reverse because we have to iterate in reverse. So let's say if you are solving the answer for this type of grid, okay, you have the answer of this one. So with this you will calculate answer of this, then you will go up row, and you will go this, something like that. Think of this if you cannot understand this, because let's say for each index, what you need is the value of this one. I mean, for each index you need the value of this cell, and of this cell. So before to calculate the value of this one, so before this, the value at cell downward to this should be calculated. That's why I am counting this down row first, then I go up, something like this. I hope you understand this. So initially I am at this I minus 1. Until I reach this thing, I just do I minus minus. And for the j loop also, it will be m minus 1 initially, and until the j is greater than or equal to 0, I do j minus minus. And now, if the I is equal to n minus 1, and j is equal to m minus 1, I'll do the continue, because I have already calculated the value of this n minus 1, m minus 1. Else what I have to do? What I have to do? So let's say if it is obstacle. Then if the mode of I comma j, if this is x, which means that it is obstacle, then as we did in this question, we just have to write the value as some. It is some much more negative thing. Let's just have it as 0 0. Okay, and then sorry, if this is the case, then dp of I comma j will be 0 0. Okay, and you just have to do continue. Else you have to see all of the three ways, and you have to find what is the maximum one there. So why not you just see the maximum one in the starting. Okay, so what you have to do is that you first calculate the maximum value. Let's say the maximum is 0 here. So if we are not at the last row, then we can go more downward. So ma will be maximum of ma will be just maximum of ma, and the dp of I plus 1 j dot first. If the j is not equal to, if the j is not equal to m minus 1, then again I will do m is equal to maximum of, you will understand why I'm doing this thing, I and j plus 1 dot first. And if I is not equal to j minus 1, sorry, I is not equal to n minus 1, and j also is not equal to m minus 1, then I know that I can go diagonal. So therefore ma will be the maximum of ma, and dp of I plus 1 and j plus 1. That's it. Now I will just, so I will have the maximum cost, right? I know that the maximum cost is going to be just ma. Now I have to find that if this is the case, and dp of this thing is ma. If this thing is equal to ma, let's just have some dumb value here, and dumb is equal to 0. Okay, so I got the maximum cost by following this case, and now I have to find the number of paths. So if this is the case, I will do dumb plus equal to dp of I plus 1 j dot second. Okay, so why not just copy this thing and paste here? If j is not equal to m minus 1, and dp of j I and j plus 1 is equal to ma. I will do dp of, in this case, and then the last thing, and then dp of I plus 1 j plus 1 is equal to ma. We do the, sorry, this dot first, then we do the dum plus equal to dp of I plus 1 j plus 1 dot second. That's it. And now my dp of I and j will be ma and dum, and I just have to return the, okay, and this thing would be in mode. I also have to do the mode here. So let's just have int mode is equal to, int mod is equal to 1e9 plus 7, and I have to do mode everywhere. So let me just do mode here everywhere. This and modulo mod dum plus mod here also. Okay, just wait for a second. And the mod here also. Okay, I hope that is correct now, and I just have to dpfij and return the dp of 0 comma 0. That is it. Okay, I did a small mistake here. So this was the max, but also I have come to this ith position, I mean the current position, right? So I also have to add this one. So the small mistake I did is this one, ma plus equal to okay, let me just do, sorry, I have to do ma plus equal to the board of I comma j minus 0. Okay, so let me explain this thing. So what I did is that I have, in this case, I have applied the bottom of dp. So which means that I, from the bottom right, I go to top left, and for each point, I have counted what is the maximum cost I can get, right? I can get. So again, as we discussed here, let I just show you for some case. Okay, so let's say I have this one, this grid. So now dp of this value is 5 2, dp of this value is 5 1, and dp of this value is 2 1. And let's say the value at this one is 2. Okay, so I mean in the board the value at this cell is 2. Just remember this thing. So what I did is this, I first in check here what is the max cost. So max cost is 5, maximum cost, right? So I know that here the maximum cost will be 5 plus adding this 2, but I will add this 2 later. Okay, so max cost is 5. Then from all of these 3, sorry, I check how many ways such that the max is equal to 2. So I come here, I check if the cost is equal to max. I mean if this value is equal to max. So this is it. So I do dum plus equal to 2, dum plus equal to 2. So my dum will be 2 now. I go to this, if it is 5, no, it is not 5. I go to this, if it is 5, yes, it is equal to max. So I do dum plus 1, so my dum is equal to 3, which means that there are 3 paths to reach here that will lead to the maximum cost. So that's it. So now this value will be 7 comma 3. That's how I count this thing. Okay, I hope this is correct, but yeah, there is going to get some error. Yeah, I knew it. Okay, I have to initialize this also as a pair of int mine. Okay, let me run and see what The error is coming. If there is some, yeah, there is some error. The error is I can't call the max here. Why I cannot call the max here? Okay, I have to do the dot first here. Yeah, I have. Okay, like it should be correct now. Okay, shit. I have to return the vector of int. Okay, I have to return the vector of int. Yeah, okay, so let's just make a vector. Vector of int vec is equal to, which will have two values. First value will be the vector of, I mean the dp of 0 comma 0 dot first, and the second value of this vector will be dp of 0 comma 0 dot second, and I just have to return this vector. It should be correct now. It should be correct now. Okay, it is correct, but I got some wrong answer. So the maximum cost I am getting is 28 in this case. I don't know why I'm getting 28. Let's read the whole question again. N is correct, M is correct, mod is equal to this is also correct. Now I make the vector of pair n cross m. The base condition will be dp of n minus 1 m minus 1 will be 0 comma 1. So the maximum cost is 0 and the number of ways is 1. From the last row and from the last column I go. If I is equal to n minus 1 and j is equal to m minus 1, I just do continue because I have calculated it already. Now, if the current value is x, if this is the obstacle, I will just do the db of I comma j is equal to 0 and just continue here. Else, I have the max value. This ma. Okay, and okay, I think I did some mistake. Okay, what if I am at this current one? Okay, yeah, so I found the mistake. The mistake is that let's say this is my grid and this is my E, right? Here is E. So this E minus 0 is also added, which I don't have to add. So if the I is not equal to 0 and j is not equal to 0, I mean, or j is not equal to 0, then only you do this, then only you add the answer. Okay, hope that should be correct now. I don't want any error. Okay, the error is in test case 3, which is in this case. Okay. I'm getting the point. Okay. So if there is some x, I am getting the error. Okay, just a second. It is a hard question. I have to check. I have to check if this is not a some x one. Okay, so the thing is that I have to also check if I cannot come to the point, come to some point, because okay, just give me a second. Hmm, how I'm going to solve this thing? Like why I'm getting errors? So I'm getting that the max output can be 2, but there are 0 ways to reach this point. Okay, so okay, I found this. So if the vac of 0 is equal to, I mean, if vac of 1 is equal to 0, then vac of 0 should be also 0. Okay, so what was the error? Oh shit, I do it. I is equal to 0. Oh shit. Okay, so I hope it should be correct now. I hope it should be. Yeah, it is correct. So, like, what was the error in my case is like, just see in this case. Okay, see the last case. The grid is like of 3 cross 3. The values are E, 1, 1, X, 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 and 1, 1, S. Okay, so the grid is like this. So now let's say how my DP is made. Okay, so this was my DP. Let me reduce this size. This is better now. Okay, so now this thing was 0, 1. The cost is 0 and number of ways are 1. This thing will be 1, 1. This thing will be 2, 1. Right. Now at this point it is an obstacle, so it will be 0, 0, again 0, 0, again 0, 0. Now I come here. I see this one. So now my MA is equal to 0 and number of ways is equal to 0. Then I do the MA plus equal to this 1. So MA will be 1, but the number of ways are still 0. So it says that the maximum cost can be 1, but the number of ways are still 0. But this is not true, right? So this should be 0, 0. So that's what I, in the last, I do here. I see here that if I mean, sorry, if number of ways are 0, then this point should also be a 0. Okay, that was it in this question. Okay, so I hope you understood this one. That was, so let's just, okay, we don't solve this question currently. Let's just, I give you a one question that is currently in my mind. Okay, this is a nice question, and from this you will learn how to make states. So the question is, let me again make it bigger. So the question is, number of paths from 0, 0, 0, 0 to n minus 1, m minus 1, such that the cost is divisible of k. This is a nice question. So in this, what you will have given is that you will have some grid, and in each cell of grid there will be a value written. Let's say the values are like this. Okay, and now the cost of a path is just the sum of all of the values in the path. So let's say if the path is like this one, this is the path. I mean, this is the path. If this is the path, then the sum is, I mean, the cost is going to be 2 plus 3 plus 1 plus 4 plus 2 plus 5, which will be 17, right? Which will be 17. And you have to check if this 17 is divisible by some k or not. And if it is divisible k, you have to count it. And you have to count all of the possible ways such that the cost is divisible by k. So think for this for some time. This is a very nice question. Think for this. and this will be a hard level question. And let if I give you hint, so the number of variables in the state is going to be three-dimensional. So you will have I, comma j, and also something in the third position. So okay, so think by that way. Okay, so I hope that you have posed for this question. I am posed for some time and then solved it. Okay, so how should we think in this question? How should we think in this question? Okay, so for this, you should know about the modular arithmetic. I mean, just the basic of it, right? What is the some number modulo k is? What is this? And num is divisible by k, divisible by k. It means that num modulo k is equal to 0. And also you have to know that let's say I mean the num plus what I mean you can just do addition in the num, which is like, let's say the num plus x modulo k will be equal to the num modulo k plus x modulo k whole modulo k. So these are the basic things you should know. So how we will learn solve this with the modular arithmetic, I mean with DP. So for that again you have to ask some question, right? Let's say you have some grid, and let's just have this grid only. You have some grid and you want to find the answer for this one. Then what data you need, right? What should be the states? Okay, so what data you need? This is the question. And again, this is a nice question. Just think for some time. Okay, and just give me a minute to drink water and think. Okay, so when you see, okay, so let's say the k is equal to 10 initially. K is equal to 10, and the grid is this one. Grid is this one. So now, like, for if this value is 5, if this value is 5, so you need, okay, just listen this carefully. If this value is 5, then what you need is the number of possible paths that end here, and their modulo 10, and the cost modulo 10, sorry, so that end here and their cost modulo 10 is equal to 5. That's you need. Because, okay, let me write here, let me just copy paste this thing, let me just copy, remove this. Okay, sorry, I paste here. Okay, this is the grid. So now just sorry. Okay, I'm sorry for mistake. I don't know what I'm doing. Okay, this is better. So now for this file, right, I need instead of this file, let's have the value 6. Okay, so now this value is 6. So I need here the number of paths such that the cost modulo 10 is equal to 4. Why? Because if the cost modulo 10 is 4, and after that this I come here and 6 is added. So this cost modulo 10 plus this 6 modulo 10, so which is the cost modulo 10 is equal to 4. So this 4 plus 6 will give me 10 modulo 10, which is 0, right? Can you understand this thing? Okay. So I need a path such that the cost modulo 10 is equal to 4 till here. And till here again, I need to find a path such that the cost modulo 4 is equal to, cost modulo 10 is equal to 4. Right. So let me see if there is a one path such that cost modulo 10 is 4. Then I would able to explain it. So the cost of this path is going to be 5, 6, 10 and 12. So let's just change this. Change okay, this was 2 and this is, let's say, 6. So now my sum of the, okay, this is also 6. So this path sum is going to be 5, 6, 12 and 14, right? This is 14, which is correct. So I want to have the number of till here. I want to have the number of paths that the cost modulo 10 is equal to 4. So let's say this is a correct path 1. So this is the one path. What is the sum of this path or cost of this path? It is 14. So if it is 14, and then from here I go downwards. So I take this path and then I go downwards. So 14 plus 6 will be 20, which is which is correct, right? 20 is divisible by 10, which is correct. So that is same for this one. I will take the number of paths, number of all paths, such that the cost modulo 10 is 4, and then I will take all of this paths, such path, and I go to left, and now my cost modulo 10 will be 0. So that is what I need. I need to have something cost modulo k is equal to 4. But and like for cost modulo 4 here I need something. So why not? Why don't we just calculate all of the modulo, right? So like I have each, let's say I at this point, and let's say the k is equal to 10. So I have all of the paths, number of paths such that the k modulo 10, sorry, such that the, let's say I store all of the values. Let's say the first value is the cost modulo number of paths such that cost modulo 10 is equal to 0, and number of paths such that cost modulo 10 is equal to 1. Then the number of paths such that cost modulo 10 is equal to 2. Then again number of paths such that cost modulo 10 is equal to 3 till cost modulo 10 uh, is equal to 9. So like for each coordinate, I count this number of all paths such that cost modulo 10 is equal to 0, 1, 2, 3 till 9. I count this thing, right? So by this I can do the transition easily. Okay, I hope you can understand this. So let's say how I do the transition. So let's say there is a grid. I am correctly at this position. Let's say I have calculated the answer of this, just as in, and now I have to find the answer of this one. And this is, let's say, 2. Okay. So now here the number of paths such that the cost modulo 10 was equal to 0, so I will take this path. So let's say the number of paths were 2. Let's say there were 2 paths. One is this one is this one. So that cost modulo 10 is equal to 0. So I will take these paths and go one to right. So now the 2 is added, right? 2 is added. So now my cost modulo 10, which was 0, plus this 2 modulo 10 will be added by, I'm sorry. Okay, sorry. Let's just take the smaller thing. Let's just take a smaller thing. Let's take the k is equal to 3 and the grade is something like this. 1 2 1 2 3 2 1 1 and 3. Okay, and this is better now. So I will make a dp. I will make a dp. Okay, this dp will have, each point will have 3 values. What are these 3 values? So first value is the number of ways such that cost modulo 3 is equal to 0, c modulo 3 is equal to 1, and c modulo 3 is equal to 2. Number of paths, like here. Okay, so I will store 3 values in each one. So for the first one, I know that the only path is 1. So this is 1, this is 0, this is 0. Okay, this will give me that the number of path such that I come to this point and the cost modulo 3 is equal to 0 is 0. There is no path. The cost modulo 3 is equal to 1. There is only one path, which is this one, and this is 0. Right. Now if I come at this point, I have to calculate for this point. So now the value is 2. So whatever path there was, so let's say there were 0 paths of this case, right? Which were the cost modulo 3 is equal to 0. So now they will add it by 2. So that's it. Something like this. So let's say the number of paths such that the cost modulo 3 is equal to 1, which is 1. So I take this path, and if I go one more to right, I know that 2 is added. 2 is added, right? I can see this 2 is added. So therefore, now my cost modulo 3, which was 1, will be added by 2 modulo 3, so it will become 0, right? So I can say that the number of paths at that cost modulo 3 is equal to 0 is 1 now. It will be 1 now. This is 0, this is 0. Right? Something like this. I hope you can understand this. So all of the paths such that cost modulo 3 was 0, you take all of these paths and you go to right, then this will be added by 2. So for all of these paths, now the modulo will be 0 plus 2 modulo 3, which is 2. Okay, so therefore this cost modulo 2 is equal cost modulo 3 is equal to 2. The number of ways are 0 here. So that's how you calculate this thing. Okay, how you calculate this thing? Okay, it is, maybe it is looks confusing, but just a second, it will be easier for you. So this will be 0 0 1, this will be 1 0 0. Okay, now comes the main point. You have to count the answer for this thing. Okay, you have to count the answer for this thing. Now you first you count this value. Okay, what is the number of ways to come this cell such that the cost modulo 3 is equal to 0? The cost modulo 3 is equal to 0. Okay, so now comes the main point. Listen carefully. So that at index 1 1, the cost modulo 3 should be 0. Okay, cost modulo 3 should be 0, and you can see that this 1 is also added. This 1 is also added into my cost. So let's say if if I find the number of ways such that the cost modulo 3 is equal to 2, where? So if I find the number of ways such that the cost modulo 3 was equal to 2 here and here, then I will go to this point and 1 is added, and now my cost modulo 3 will be 0. Can you understand this or not, right? So if I need to find the value of this thing, cost modulo 3 is equal to 0, I will go here and ask him that, hey, how many ways there are to reach till u such that the cost modulo 3 is equal to 2. If he says that I have two ways, if he says, let's say he have two ways, so then by these two ways I will go down, and now my cost modulo 3 will be 0, because there were this was 2 plus this one, so this will be 0. That is that correct? So now this will be 0. Now I come here, the cost modulo 3 is equal to 1. Cost modulo 3 is equal to 1. So I know that in the last, in here and here, I will see how many paths there are such that the cost modulo 3 is equal to 0. I will take those paths, and now if I take these paths and come here, so this 1 is added, and now my cost modulo 3 will be 1. Okay, so let's analyze it. Okay, so let's say I have to find the number of paths such that cost modulo 3 is equal to 1. I go here, I ask him that how many paths there are such that the cost modulo 3 is equal to 0. He will say there is only one path, which is this one, which is this one. Okay, so you know the modulo 3 is 0 till here. Now I go to left, I go to right. Now 1 is added. So now in this path, the sum is 4, which means that 4 modulo 3 is equal to 1, which is correct. So that's it. So till here the sum is 3, so 3 modulo 3 is equal to 0, and then after this I go to here, and for this path now my cost modulo 3 is equal to 1. The number of ways are 1, and here is also 1, so 1 plus 1 is equal to 2. This will be 2 and this will be 0. I will just count something like this, and what is my answer? Answer is just this point, that dp of n minus 1 comma m minus 1 comma 0. So what is the state? The state is going to be dp of I comma j comma x, which is the number of ways to reach coordinate I comma j such that the cost modulo k is equal to x. So that's how. So this were the case. I mean, this was just for grids, and this is the extra state. So this is the data. I mean, you have to count the answer, right? So that's how you found that you need an initial state. And what are the transitions? So transitions are again very easy. The transition like this: dp of I comma j comma x is going to be dp of I minus 1 comma x. So you see left of you, and what the modulo should be. Now the modulo should be x minus ARR of this ij. How? Because the modulo is x minus ARR of ij till here. Then you go to this ij, and this ARR of ij will be added. And now my modulo is x minus. So like what I mean is that, let's say the modulo is x minus ARR of ij till this point. Then it will be added, right? The ARR of ij will be added, and these two are going to be cancelled out, and you will have x anyways. So this is it, and plus dp of I j minus 1 and x minus ARR of I comma j. So these are just the transition, and that's how you are going to get the answer. So transition are again very easy, and code of this question is going to be again a easy one. So this is again like do it yourself. Okay, So these are like the main, most of the grid question are like this. So the main first two states in the greedy will mostly will be I and J. Here you will have some extra states. Okay. I mean, let's say it can also be like you have to care about if the last index were taken or not, and then you just make DPS I, J, X, and then taken or not taken, take, not take, something like this. So yeah, you have to add this other states according to you. Okay, these two states are just for the position, and that's how you can think of this grid DP. The IJ are common, and then you have to find the answer. I mean, find other states. The transition are mostly easy, and remember this. And remember this. If in grid, if if you can go to right and down, or what, or RIGHT, or left and up, then most probably it is a question of DP. But if you can go to any direction, I mean you can go to up also, down also, left and right also, then it is the question of graph, like by DFS or Dijkstra or something like this. But it cannot be solved by DP. Why? Because let's say just see the case of recursion. Let's say you want to find the answer of this, you go down, you want answer of this, then you go right, you want answer of this, you want answer of this, and for this you get answer of uh, you want answer of this. So this is a cycle, and you will be just a loop in a cycle, and this thing will now give you of n time sorry, this will be give you a TLE. That was the other thing you have to remember. Okay, now there are also some other cases, some other questions you have to solve, which are the nice question. And if you are able to solve this three question, if you solve these three questions, then you have just mastered the grid DP. You don't have to do anything else. Okay, let's read the other questions. The question is this one: maximum non-negative product in matrix, which is just the maximum product you can get. Okay, the maximum cost of a path you can get, and cost is just the product of all of the elements in the path. So this is again very easy, as we discussed in the previous lecture. About one day we discussed a question where we have to find the maximum sub-array product. This is something like that. You have to store the maximum and minimum. Okay, I hope you remember that. And this is again going to be very easy for you. So the one thing will be just the maximum maximum product with the positive sign, and the other state will be the maximum product with the negative sign. And that are the two things you have to remember, two things you have to store, and this is going to be very easy. This is going to be a nice question. Okay, so in this cherry pickup, there is one robot, one robot here, one robot here, and what you can go is that each robot can be go diagonal, can go down, or can go into right diagonal, and you have to calculate the maximum sum of the path of these two robots. This is a nice question. Okay, this is a pretty nice question. So this is a homework for you, and this third question also is going to be a homework for you. So try to solve this on your own. Okay. Oh, this is the best question of the today. But let's say I just solve this question. Let me explain how should you think in this case. Okay, this thing was nothing. So for each, what are the different possible ways? Okay, I mean like in this cherry pickup question, cherry pickup, you have to like think for what are the all of the possible states you should have, I mean, okay, or what are the possible cases you can have. So I mean, if there is one row, this is some grid. So the one thing is that the robots are going to be always at the same row number, right? This is it. Let's go here. It can go here. It can go here. It can go here. This can go here. This can go here and here. But you can say that the row number is always same. So what are the things that are different? The things that are different are their column number, right? So from this you have to think of something. So try to think like this. Try to make some states. So why don't, yeah, the basic approach in this case is, like, while making states, is just having all of the possible, I mean all of the possible values. So you can have some DPs like this: I, J1 and J2. What is this? So it is the max answer when robots are in ith column, I'm sorry, ith row, and first robot in J1 column, and the second one in J2 column. Okay, that's it. And now the transition are again very easy one. So try to think for this case. Okay, so like whenever you see the DP question, the first thing you should care about the size of this. This is 70, so you can have easily have the n cube approach, and that was the approach you have, right? Okay, so I guess that was it in the current video. If you have some doubts or some feedback and some suggestion, you can write in the comment sections, and I hope that you have some doubts in some question and you ask me. So that was it for today, and meet you in the next video.